Alright, you guys, if you could please turn to section 12.2 in your notes. We're going to go over surface area of prisms and cylinders. Alright, a prism. A prism is a polyhedron with two congruent faces called bases that lie in parallel planes. The lateral faces are basically the other sides, the other faces of the polyhedron. They are parallelograms that are formed by connecting the corresponding vertices of the bases. Alright, I also drew a picture over here illustrating what I'm talking about. Here are the bases, here are the ones on the sides are the lateral faces. Okay. Lateral edges are basically the segments connecting the vertices of the lateral faces, so these segments here. Okay. Surface area. The surface area of a polyhedron is basically just the sum of the areas of all its faces. So if you were to take the area of this face, all the faces, and add them all together, that would give you the surface area. The lateral area of a polyhedron is the sum of the areas of its lateral faces. So if I were to just take the areas of each of these lateral faces, that would be the lateral area. Alright. A net. Imagine that you were to take some edges of a polyhedron and cut them off and then unfold it like a piece of paper. The two-dimensional representation of those faces is called a net. Alright, I drew another little picture over here. If you were to take a cube and unfold it, it might look something like this. This would be a net. Alright. A right prism. In a right prism, each lateral edge is perpendicular to both bases. In an oblique prism, the lateral edges are not perpendicular to the bases. Okay, once again, I tried to draw some pictures. This one is a right prism, this one is a prism that's slanted. Looks kind of funky, but hopefully it works. A cylinder is a solid with congruent circular bases, so it looks kind of like a soda can. Okay, so here's my soda can. And finally, a right cylinder. In a right cylinder, the segment joining the centers of the bases is perpendicular to the bases. Okay, so this hopefully looks something like a right cylinder. All right, let's go on to page 2. Theorem 12.2, surface area of a right prism. The surface area S of a right prism is 2b plus pH. Or you could write it AP plus pH. Where A is the apothem of the base, B is the area of the base, P is the perimeter of the base, and H is the height. Alright, now, an apothem is the distance from the center to any side of the polygon. So, for example, if I have a triangle, and this is the center, and this is the center of the triangle, this would be the apothem. It's just a line from the center to the edge. Okay? Alright, example 1. Find the surface area of the right prism. Each base of it is an equilateral triangle with a side length of 6 inches. Using the formula for the area of an equilateral triangle, the area of each base is this. Okay? Six squared is 36. 1/4 of 36 is 9. Another way you could do this, which might be a little bit easier, if you have an equilateral triangle where the bottom is 6, where each side is 6, this would be 3, and this would be 3. This is a 30, 60, 90 triangle. The long leg of a 30, 60, 90 is √3 times the short leg. Area of a triangle is 1/2 base times height. Half of 6 is 3. 3 times 3 root 3 is 9 root 3, which is the same answer we got over here. Okay. Alright, the perimeter of each base, if it's a triangle on each side, is 6. The perimeter is 18. The height of the base is going to be the segment that connects the two bases. So in this case, it's going to be 8. Okay, so 2 times b plus the perimeter times the height. Let me pull out my calculator here. Alright, here's my calculator. 2 times 9 is 18. 18 root 3 plus 18 times 8. There we go. So it is approximately 175.18. So the surface area is about 175.18 square inches. Okay. Complete the following exercise. Find the surface area of a right rectangular prism with height 5 feet, length 11 feet, and width 4 feet. Go ahead and pause the video here and try this one out for yourself, and then hit play when you're ready for the solution. Alright, this is the answer you should have gotten. Okay, let's go on to page 3. Theorem 12.3, surface area of a right cylinder. The surface area S of a right cylinder is S equals 2B equals CH. B is the area of the base and C is the circumference, or you could write it like this. Hopefully you guys remember the area of a circle is pi r squared, and the circumference of a circle is 2 pi r. So you could write it like this instead. It's pretty much the same thing. Example 2. Find the surface area of a cylinder. Find the surface area of the right cylinder. Each base has a radius of 4 meters, and the cylinder has a height of 5 meters. So let's plug all this stuff in. R is 4, H is 5. 4 squared is 16. 16 times 2 is 32. 4 times 5 is 20. 20 times 2 is 40. 32 pi plus 40 pi, that would be 72 pi, which is approximately, alright, here it is, 72 pi. There we go. It's approximately, oops, 226.19. square meters. So the surface area is about 226.19 square meters. Alright, checkpoint. Complete the following exercise. Find the surface area of a right cylinder with a height of 9 centimeters and a radius of 6 centimeters. Round your answer to 2 decimal places. Go ahead and pause the video here, try this one on your own, and then hit play when you're ready for the answer. Alright, this is the answer you should have gotten. In general, you don't have to convert pi to a decimal if you don't want to, unless it specifies, unless it tells you that that's what it wants you to do. Okay? Excuse me, sorry. Alright, let's go on to page 4. Okay, example 3. Find the height of a cylinder. Find the height of the right cylinder shown, which has a surface area of 198.8 square millimeters. Alright, so basically now they give us a surface area and we have to work backwards. Substitute known values in the formula for the surface area of a right cylinder and solve for the height h. Alright, so S equals this equation. We know the surface area. Okay, and we know the radius. Okay? Alright, let me use my calculator over here. 2.8 squared, that gives me 7.84. Multiply that by 2. 15.68. And over here, 2.8 times 2, let me see, that'll give me 5.6. Okay. So, 198.8 minus 15.68 pi will equal 5.6 pi h. (198.8) minus 15.68 pi is going to be approximately 149.54. Now I'm just going to divide by 5.6 pi. Okay, 83.89. 83.89. Okay. And you can fill these out too if you'd like. It doesn't really matter if you don't fill these ones out. It's alright. Might come in handy if you go back and you wonder how you got from one step to another step. Alright. Checkpoint. Last one. Complete the following exercise. Find the radius of a right cylinder with the height of 5 inches and the surface area of 168 pi square inches. Go ahead and pause the video here, and then when you're ready for the answer, hit play. Alright, and here's the answer that you should have gotten. Okay, once again, please make sure to take the quiz. It should be in the notes of this YouTube video. And yeah, I will see you guys tomorrow.